Hi, welcome to the 6502 show. Today, we're going to take a deep look at a high-level language that was written back in the mid-60s for the PDP-8. But we're going to take a look at FOCAL-65, written specifically for 6502 computers. Now, there's precious little on YouTube about FOCAL, so let's do something about that right now. Before we get started into our deep dive with FOCAL-65, let's go back to the beginning. 1965, and DEC had released the PDP-8, and it took mini computing by storm. They sold a couple 10,000s of these things. That was a lot of units back then. And along with your PDP-8, you needed some way to talk to it other than the blinking lights and the flippy switch, so you needed to have a teletype. This is an ASR-33. Almost ubiquitous in the 60s and 70s. Well, the PDP-8 came with Fortran. It wasn't long before people wanted to do other things with it, and Rick Merrill wrote FOCAL for the PDP-8 in 1968. And right on the cover of the very first book about FOCAL, it says, "A new conversational language developed by Digital Equipment Corporation for the PDP-8 family of small computers." So, clearly, they were trying to sell the idea that this is going to be easy to use, or easier, should we say. And what we see here is a little bit of code. This is FOCAL-69, revised by Ed Taft, but still maintains Rick's top billing on the credits. Well, FOCAL took off like wildfire. There are more programs that were written for FOCAL on the PDP-8 than there were basic programs written for the PDP-8. Let's just take a quick look through the DEC's catalog for 1978. Now that's a lot of programs. It's 229 to be exact, and only 42 of these are games. The rest of them is mostly all about math and science. And, people were writing things from all over. Let's just take a look at this last page here. Here we have the Netherlands, people writing it in FOCAL-69, University of Leicester in England, someone in Bucharest, Romania, writing a production problem for radioisotopes. It goes on. And then some kid from Don Bosco Technical High School. Patches to programs from the University of Washington here. All kinds of things. It really was a worldwide phenomenon, and there were many, many programs. One of the things you'll see on this first page, right off the bat, the Sumer Game by Doug Diamond. This is Hammurabi, and it was on every timesharing system in the 70s, and of course found its way into 101 basic games, edited by David Ahl when he was still working at DEC. One page in particular I wanted to show you is right here on the top left, FOCAL Lunar Landing Simulation by James A. Storer, Lexington High School. That is Dr. Jim Storer, all right, when he was a teenager, and he was just enthralled. He's told this story on the internet. Enthralled with the space program, wanted to write this thing, got some help with the equations, and put it together in FOCAL. This is its original native version. This thing was a lot more popular than people remember today. Here is the command set of FOCAL-65, and it adheres pretty darn close to the original. We have ask, which is an input command. Here we're going to ask for 3 different variables. We can add comments or continue. It just kind of depends on context. Go and do something is to call a subroutine. And when that group is done, you'll return back to the end of the do statement to finish out the rest of the line or move on to the next line. Erase gets rid of a line, as you can imagine. The for statement needs a little bit of conversation. This is set up like Fortran, pretty much. We're going to have I from I to X to Z, step Y. Or if we eliminate the step and just go for I equals X to Z, then the step is assumed to be 1. And then any commands after that will be executed inside the loop. But the loop has to fit on one line. There is no next statement that you can put somewhere down the road. It all has to fit on one line. One way around that is to, after your for statement is defined, you can use as one of your commands do and send it down to do a whole group of things that you want it to do if it just won't fit on one line. Well, as is clear, there's no way that all 4 lines in group 3 would fit on group 2, line 10 at the do statement. So we broke it up, turned it into a little subroutine, and it'll work just fine. Watch. What's it got against 7s anyway? Go is, well, it's go. Go to. Do it. If also bears some discussion because you can't, you can only evaluate if something is less than 0, if it is 0, if it is greater than 0. And you will go to a line number. You can't do anything after that, but you will go to a line number. What we could do is something like this. Now, here, what I'm saying is x equals 0. So if it is not 0, I'll go to this group and line, and I've got a blank space where the 0 jump would be, and then I've got a branch for if it is greater than 0. And then, after the semicolon, I've got commands. So this will tell me, hey, if this equals whatever it equals, if it's equal, and I do the subtraction, and it's 0, and because I don't have a branch, those commands are going to execute, and then it'll fall through to the next line, or as the last line I could have, and, go someplace else. All right, let's feed it a number. How about I type go and enter X, and let's say I give it a 5, which will make B 10, and I'll make X 4 minus 10 minus 6, so I'll have a negative number. Yep, he sure is less than 0. Let's give him a negative number. So we'll end up with, say, 4 minus negative 8 is positive 4. You betcha. And of course, we have to make sure that we get our 0 test in. All right. Modify is an editing command that I have never used because I'm not editing natively on the machine. I'm not using the editor for much of anything. And that's all done offline and then fed up through TTY. On is essentially an if statement that works instead of jumping to a place, you do a JSR. So these would all be calling subroutines. I think I've used it once. Quit is quit. Quit the program. Stop. Stop doing what you're doing. Return from a subroutine, from a do loop. If you wanted to return early, if you didn't want to go through the entire group number, say you said a do 4, and you wanted to return in the middle of it, you'd use that. You can also use it to break out of a for loop a little early. Set is essentially let in BASIC, and it is mandatory. If you're going to do any type of assignment to a variable, or you're going to call one of the functions, you have to use set. Type is print, obviously. Guess I could have made that a little prettier by making it go there. And write is not necessarily what you'd think. Write is list, as far as BASIC would go. This will list out the entire program. This will list group 1. This will list group 1, line 1. So you've got pretty much everything you need here to move around inside of a program. Now let's talk about functions. In the math department, we're a little light. You've got absolute value. You can return the integer value or a rounded integer. If it's 4.5, you'll get 4. If it's 4.55, you'll get 5. You can generate a random number, and by throwing a -1 in there as your first usage, you randomize it. You can examine and write to memory with the function fmem, and the values that you'll use are decimal, so be aware of that. String functions are, believe it or not, fairly robust. They're a little weird if you're used to Microsoft Basic anyway, but they function quite well. You can spit out a character of ASCII, you can input a single character, but you can also build strings. You can input and output them, set their length so you're dimensioning a string essentially. Single dimension, mind you. And then we will move on to the next slide.
Next slide, please.
We have some control functions that work with the string functions as well. And I put a couple little examples there. But the first control function is jumping to a subroutine. We will go to a group G, pass the value to it. And that's going to come in handy in a second. I'm going to explain why. Function for input device and output device is what you can do to build long strings. So in the first example, I've set the output device as a string. So I'm going to type hello world, and I have a delimiter. It can be anything you want. It could even be a carriage return for that matter. And then I'm going to reset the output back to the terminal. In the second example, we're going to set our input as a string, not the keyboard. So then we'll output a string until we hit that delimiter and then reset our input back to the keyboard. Now, going back to the first slide, as I pointed out, there are very few math functions. Well, what you can do is write your own and then call them with the subroutine function. And here are some basic stuff that comes in really handy. Sine, cosine, tangent, arctangent, natural log, and square root. With those, you've got a full complement. Now, mind you, these would run a lot faster if they were written in machine language and I could call them with a machine language call. Which brings me to this appeal. We need the source code for FOCAL-65, either version, Program Exchange or Arenco. For over, in some cases, 20 years, people have been looking for this. And there's so much more we could do with FOCAL if we just knew where to latch on to things. I mean, they're tantalizing little bits and pieces. Here's some code to add a machine language jump off, like a user function, so that you could call a machine language program. There's lots of other things we could do. Cassette interfacing. We could do PIA and Riot interfacing. Lots could happen. So if you have the source code, please contact me and let me know if I can have a copy. It would be much appreciated by most of the 6502 community. Okay, back to the show. Well, it wouldn't be the 6502 show if we didn't run a few programs. So let's start off with a program called Code Generator, and this builds a Vignere cipher table. And a Vignere cipher was invented way back in the 16th century by Giovan Battista Bellaso. And it has the name of another mathematician, But nope, he's the guy who put it together. There's a lot more information in the description below where you can go to find out about the Vineary cipher. Well, let's put this program through its paces, and while it goes, I'll show you a little piece of the code that's kind of interesting. So we're going to set up our matrices and then build code tables. And while all that is going on, and an airplane is flying quite low overhead, let's take a look at the code here. And the line to look at is group 1, line 70. And this is an example of what we were talking about with 4 next earlier. There is no way that all that code in group 4 would have fit on one line, doing the Z equals 1 to 26. So we just call it as a subroutine. Pretty smart. This part takes a while, so I'll move ahead. All right, all done. Pretty cool. You can send secret messages to your friends with a code that was broken about 160 years ago. Next up, we'll play a little bit of tic-tac-toe, but of the 3-dimensional variety. Okay, we've got 3 boards, top, middle, and bottom. Computer plays X. I play X. It plays O. It's going to need a lot of time to think in the late stage of the game. My move first, my move 14. Well, apparently this thing will always win when it's 14. Well, I'm going to take 25. Okie dokie. I'm going to take 19. I'm yet to beat this thing, by the way. And I won't play out the whole game because we can see where we're going. It already just got a line, a diagonal line through the middle. So it's up one on me. I could go 19, 20, 22. And I'll pick up a line there, but it's going to set itself up. This code is excellently commented, and there's no reason to get all twisted up about having single-letter keywords and statements and things. I know some people really rail against that. Oh, I can't read it, it's impossible. Well, when you were dealing in environments that only had 4K of RAM to begin with, every byte was precious, and so you did squeeze those things, and it becomes natural. You don't even think about it after a while.
I don't even see the code. All I see is blonde, brunette, redhead.
Think about VTL too. You can handle that, right? Focal will be a breeze. The author, who is Leonard Furtuk, he came up with some alternate rules because when the computer goes first and it picks the center square in the center board, it will always win. It cannot be beaten. So he has some alternate starting rules to give you a fighting chance. And of course, in Group 10, I just couldn't resist putting in my own special touches. But both the program that we saw before and this program came from the DEC library. There are literally hundreds of programs in there that can be adapted for use with FOCAL-65, and we can enjoy today after having rescued and adapted them. I want to thank you for watching the 6502 show today, and I hope you enjoyed this deeper look at FOCAL-65, a really wonderful interactive language. There's just about nothing you can't do with it, so have at it, folks. A paper tape file of FOCAL-65 is available on my website, along with some documentation, so you can dive right in and have a good time. Okay, don't forget to like and subscribe to this video, and until we see each other again, take care.